Hello everyone, good evening, hi, welcome to Unacademy. Good evening all, how are you? Bharat, Satish. Yes, I'm also good. So let me introduce myself first, then after we will discuss the session. My name is Banu Prakash, expert in GATE, ESE and PSC coaching. I did MTech from NIT Kurukshetra. I have 10 plus years of teaching experience and I train many students throughout our country for different competitive exams like GATE, ESE and many more PSUs. I expertise in the subjects of electrical machines and power electronics. BPC 10 is my referral code. So use this code, you will get 10% to discount on Plus subscription as well as Iconic subscription. And what are the benefits of the Plus and Iconic subscription? By taking Plus subscription, you can get live classes from the top educators of the country. Here we have a choice to select the teacher per each subject. That means there are many number of the teachers per each subject, so that you can select the teacher as per your choice. And second one is we will get structural schedule and unlimited practice questions. Okay, these are the two advantages by taking Plus subscription. And one more important benefit of Plus subscription, that is the test series. It is a very useful for your GATE ESC preparation, and also if you want to write any other competitive exam, test series is a very important factor to crack the exam. Okay, and one more subscription, that is Iconic subscription. By taking Iconic subscription, you can get all these four benefits. In addition to these, you will get some other extra benefits. One is the personal coach. The personal coach means, okay, that is a one-to-one guidance for your GATE, ESC and PSU's preparation, and he will guide everything until you crack your exam. And also one more thing, that is the study planners. You will get proper study planners and expert guidance, ESC mains questions and answer. So Iconic subscription is a complete package to crack your exam. You will get all type of the benefits. So use my code. Okay, if you want to use these benefits, and use my code BPC10, it is my referral code. Use this code, you will get 10% to discount on Plus subscription and Iconic subscription. What about the fee structure for the Plus and Iconic subscription? The Plus subscription is available for 12 months, 18 months and 24 months. For 12 months fee is 27,225 rupees. For 18 months fee is 34,650 rupees. For 24 months fee is 39,600 rupees. So this is about the fee structure of Plus subscription. And another subscription is, that is a Iconic subscription. So it is available for 12 months and 24 months. For 12 months fee is 45,225 rupees. For 24 months fee is 66,600 rupees. So this all about fee structure of the Plus and Iconic subscriptions. Okay, and we have a question, how to install Unacademy learning app. It is a very simple. Go to Play Store, search Unacademy learning app, and after that install this app in your phone. So after the installation, and you can access the pre-special classes taken by the top educators. If any the code is asking, just use my code, that is a BPC10. So it is also invitation code to access the pre-special classes. And another one is a, if you use this code, you will get 10% to discount to in order to take the subscriptions. Okay, And this is some exciting announcement in the month of the December from the Unacademy Gate English channel. So I think we know that our channel changed from the Unacademy Gate Telugu to Unacademy Gate English channel. This month schedule communication system, the this communication system deals by Nageshwar sir. So from 9 to 10 a.m. engineering mathematics 10 to 11 a.m. So this subject dealing with by the Inkat Krishna sir. Another one is analog electronics course and electronics from the 4 p.m. 4 to 5 p.m. Foundation course for the GATE 2022-23 maths. So this subject is a dealing with the Inkat Krishna sir. This is the 5 to 6 p.m. Ellen Sharma sir foundation course for the aptitude and 6:15 p.m. to 7:15 p.m. And another the new initiatives. One is this one is a GENCO TRANSCO discoms the AE and AEE SSC. So that is the measurement subject. Okay, measurement subject is dealing by the Surendra Bab sir. So timing is 7:30 to 8:30 p.m. And another one is electrical machine. I'm dealing this subject from 8:30 p.m. to 9:30 p.m. for GENCO, TRANSCO, DISCOMS and SSC RRB batch. Okay. Good evening all. Very good evening. How are you all? Suraj, Pavan, Bharat, Satish. Okay, that will be continue electrical machines class also. This is the extra course. We will announce the timetable soon. Shiva, any more question do you want to ask? You can ask. Definitely, Kranti, we will start the one batch in Unacademy place. It will be updated soon, very soon. So we are planning to take one special class, that is a special classes plus classes in the Unacademy learning app. Any more question do you want to ask? You can ask any type of question. I will answer here. Okay. So these are the some exciting jobs for our electrical students. One is a TS GENCO, TS TRANSCO, and AP GENCO, the AP TRANSCO, and some other Maha GENCO. This is for Maharashtra students, and TN GENCO like Tamil Nadu State Generation and Distribution and Corporation Limited jobs. So these are some exciting jobs for all electrical aspirants. One more is the SSC Junior Engineers RRB JE requirement, and these are the different type of jobs. Okay, and for all type of the jobs, suppose if you want to write TRANSCO, GENCO, any SSC, RRB, the syllabus is the remain same, but little bit change. Almost 90% of the syllabus is same for all type of the exams. So in our class, we will discuss all the questions, previous questions of the TRANSCO, GENCO, SSC, RRB, and also previous IAS question and GATE 1 mark question. All type of questions we will discuss one for the each chapter, and for the transformers, DC machine, synchronous machine, induction machine, for every part. So we have a correct plan to guide you how to get how to crack these exams. We will discuss very soon. And okay. Yes, Mahendra, actually we have started the mission, but that is exclusively for the GATE and IAS. So this batch is exclusively for state electricity board exams. For every state electricity board exams, SSC JE, RRB JE, and also especially for our Telugu students, that is the TS Transco, TS Genco, AP Transco and AP Genco. And for Tamil Nadu students, that is Tamil Nadu Generation Distribution Corporation, TNGEDD jobs. Okay, that is also some very good jobs for Tamil Nadu students. And for Maharashtra students, okay, that is Mahagenco. Every time we have seen many jobs in the Mahagenco. So we will provide all the exam coaching at one place. This just like a one-stop solution for all electrical jobs. So previously also have started electrical machine, that is exclusively for GATE and ESE. Is that clear, Mahinder? Yes. Any more question do you want to ask Mahinder? Suraj? Suraj, where are you from? Yes, actually, actual timing previously we have taken the missions class at 4 to 5 p.m. but timings were changed. So we will discuss with the team and we will announce that new timetable for electrical missions class later. Yes, Maharashtra. Okay, you know that about. I think you heard about the Mahagenco jobs. Yes. Satish, I can't send all the questions to you, but I will discuss here all the state electricity board exams questions, all type of questions, even in the any type of state electricity board exams. We will discuss in this place. I have mentioned already. It is just like a one-stop solution to crack your AE exam. Yes, Mahinder, I will try to take 2 hours, but today I will start 1 hour. Then the next week onwards, we will discuss about the 2 hours class. Okay, mostly I will take 2 hours class. Sure. Shiva, Satish. Okay. I will discuss all type of questions. You don't worry about the question. And also one more thing, to crack AE, the State Electricity Board Assistant Engineering exam. So there is a electrical machines questions. Most of the question comes from the objective questions of the PS Bimra textbooks. Do you know this? Yes or no? Okay. So these are the, let us see the syllabus. Okay. Suraj, actually, most of the questions for AE exams comes from the in the missions part comes from the objective questions of the PS Brimra. So that questions were very important for AE exams. So mostly I will take this, what for each topic I will discuss all type of previous state electricity board exams question, and also I will add some questions of the PS Bimra question in that topic. Okay. So let us see the syllabus for some state electricity board exams. This is the GENCO syllabus point of view. So in transformer part, okay. Just wait a minute, please. Okay. Satish, what's your question? This year, any chance for AP AEE notification? Please tell me, sir. Okay. Uh, Mostly this year, most of the notification comes. So you don't worry about the notifications. Please concentrate how to learn the subject. You must learn the subject and ready to write it every time. You have to ready to write the exam. But don't think about the most of the time about the notification. It's not correct approach. So first you learn the subject and practice more questions. Then after, when the notification comes, you first you are in the queue. You are in the first in the queue. Okay. So in the GENCO syllabus point of view, so we have a one is a the transformer part. Okay, and second one is, okay, this is the single phase transformer and equivalent circuit, that the test. Okay, what are the tests here? So we know that that is the open circuit test of the transformer, okay, and short circuit test of the transformer, and one more is a polarity test of the transformer. Okay, these are the test. One more is the back to back test or Sumner's test of back to back, the test of transformer, or heat run test of the transformer. So another part is a the regulation. The regulation means voltage regulation of the transformer, efficiency of the transformer. So this is the syllabus of, okay, single phase transformer syllabus. So most of the question comes from the equivalent circuit, the testing, regulation and efficiency part. So in case of the three phase transformer, so that is a most of the question comes from the parallel connections. So what are the connections here? Delta delta three phase transformer, star star three phase transformer, star delta three phase transformer, so delta star three phase transformer. So conversion also very important. So that is a star to delta, delta to the star. Okay, this part, the three phase transformer connections. Okay, and next one, parallel operation and auto transformer part. Okay, this is the syllabus of the GENCO. So for TS and also AP GENCO and the TS GENCO. So this is the auto transformer part. So this is complete syllabus of the transformer. Okay, single phase transformer, auto transformer and also three phase transformer. And next one, the motors and generators point of view. One topic is a principle of the energy conversion. So what are the principle to convert the mechanical energy to the electrical energy, and electrical energy to the mechanical energy, this type. And next one, windings of the rotating machine. Windings, nature of the winding in the AC machine, DC machine, and that is a lap connected armature winding, wave connected armature winding. This part we will discuss. And next one is a DC generators and the DC motors and characteristics. This is a very important for the AE exams. The mostly the questions comes from the characteristics. Okay, starting and the speed control of the DC motor. So this is the syllabus about DC machines. And another part is the three phase induction motors, characteristics, starting methods and speed control. So what type of characters? That characteristics means torque slip characteristics. Okay, variation of the torques by varying the torque, that is the torque slip characteristics. And single phase induction motors. So what are the types and characteristics? And synchronous generators point of view, performance analysis. Okay, regulation, it is a very important part in the synchronous machine. And parallel operation, most of the question comes from the these two areas, regulation and parallel operation. And synchronous motors, okay, starting characteristics and application. And synchronous condenser, what is the mean by synchronous condenser? Synchronous condenser means overexcited synchronous motor without any mechanical load on the shaft of the motor. So another one is fractional kilowatt motors, that is the capacitor start motor, capacitor run motor, capacitor start and capacitor run motor. And small discussion about the permanent magnet, PMMC, the DC motor and stepper motors. Okay, this is the syllabus about the GENCO. And let us see the syllabus of the TRANSCO here. TRANSCO is the remain same. So this is in case of the single phase transformer, equivalent circuit, phasor diagrams, the test, regulation and efficiency. Okay. And three phase transformer connections, parallel operation, and another one is a auto transformer part. So comparison point of view, in the GENCO, there is no the equivalents here is a in the GENCO part there is no the vector diagram syllabus. Okay, but here is a vector phasor diagrams was mentioned here, but there is no much difference. We will discuss about all equivalent circuit, phasor, testing, regulation, efficiency, three phase transformer connection and everything. Okay, and similarly in the DC machine, okay, here types, winding, generators, motor characteristics. Okay, and here some extra part is a armature reaction and commutation. So armature reaction and commutation, so which was not given in the GENCO part. Okay, DC generators and characteristics, but we will discuss complete armature reaction effect and also commutation part. So for any state electricity board exams, these two parts is a very important in the DC machine. So we can make any type of question from the armature reaction commutation part. So that's why it seems to be easy and somewhat difficult. If you know the concept very clear, then only you can answer this question. Otherwise, it is a very difficult to two answers. Okay, am I right? Next one, starting and speed control of the motors, three-phase induction motors, principles and performance characteristics, starting and speed control of the three-phase induction motor. So almost 90% of the syllabus is a remain same the in TRANSCO and GENCO exams. Okay, and next one, let us take the SSC JE. Okay, this is a for electrical machine. So there is a DC machine part, AC machines, and also transformer part. Okay, in case of the transformer, single phase. Okay, first part is the DC machine, and another one is single phase and three phase transformer. Okay, third one is three phase induction motors. Okay, and fourth one here, this is a fractional kilowatt motors. Okay, and synchronous machines. Okay, like most of the syllabus covered in the SSC JE, so that we will discuss every part. Okay, that is a very important the to crack any competitive exams. Okay, don't leave any single topic also. So discuss very in details, and also we will solve some questions based on each topic. Okay, now tell me any more question do you want to ask? Okay, so electrical machine subject I will divide into the three chapters basically. So one is the transformers, DC machines and AC machine part. So in the transformer part, already we have seen that there is a first part, it is a one part is a single phase transformer part, and second one is, otherwise I will write completely here, the single phase transformer, and second one is a three phase transformer. Okay, and third one is the auto transformer part. Okay, the syllabus point of view, in case of the transformer, most of the question comes from the single phase transformer. That is, the syllabus is a more in the single phase. The syllabus of the single phase transformer is a more as compared to the three phase transformer and auto transformer. So mostly 80% of the question comes from in the transformer part. 80% of the question comes from the single phase transformer. Okay, and 80% of the weightage, okay, and remaining 15% of the weightage is the three phase transformer, and 5% less discussion about the auto transformer. So the syllabus is the less in the auto transformer, but every competitive exam you can expect one question from the auto transformer part. That is the important thing. Your syllabus is a very less as compared to the single phase and three phase transformer. So but every time you can expect, in every competitive exam you can expect one question from the auto transformer part. Okay, all of it clear? And next one, in the DC machine, so there are the two parts basically. One is a DC generators, and second one is the DC motor. Here the discussion about the DC generator and discussion about the DC motor are equal, so that 50% of the question comes from the generator part and 50% of the question comes from the motor part. So this is about the DC machines. And in case of the AC machine, so there are the first one is a, so it is a three phase the synchronous generators, or it is also called alternators. Here this part is a very important for the in the AC machines one. Okay, and second one is a three phase the synchronous motor part, synchronous motor, and third one is a three phase induction motor. Got in point? Three phase induction motor. And fourth one, it is a so single phase or three phase induction generator. It is a small discussion about the three phase induction generator part. Okay, little discussion about induction generator. And fifth one is a single phase, okay, induction motors. Okay, what are the single phase types and characteristics, equivalents are equal? So that is a single phase induction motor. And fifth part is a the single phase the synchronous motors. So there are the two types of the synchronous motor. One is the hysteresis motor and also reluctance motor. These are the single phase synchronous motor. And seventh one is a some special machines. Okay, the special the machines. So here we will discuss, that is the stepper motors. Okay, all type of the special machines we will discuss here, or servo motors, stepper motors. Okay, this type of the special machine. So this is the complete syllabus of the electrical machine. The chapter 1 is a transformers, DC machine and AC machines part. Okay, so in case of the single phase transformer, so mostly we will discuss starting point. The first one is a that is the features and operating principle of the transformers. Okay, this is the first topic. In case of the transformer, it is operating principle of transformer. Okay, and second one is a we will discuss about the EMF equation of transformer, and third one is a constructional details of the transformers. Okay, what are the types of the constructions? Okay, core type transformer, shell type transformer. How do we place the winding on the core type transformer and shell type transformers? Okay, and fourth one is a another part. The fourth is a ideal transformer. Okay, in case of the ideal transformer, so here we will discuss about equivalent circuit. Okay, this is a what is the mean by ideal transformer. Okay, and also we will discuss about and how to draw the characteristics of ideal transformer, and how to draw the equivalent circuit of ideal transformer under loaded condition and also no load condition. And after that we will discuss about the vector diagram of ideal transformers. Okay, this is our discussion in case of the ideal transformers part. And fifth one is a we will discuss about fifth part. So that is the practical transformers. Okay, in case of the practical transformer, so operation of the practical transformer by considering the characteristics of the ideal transformer. So for example, operation of practical transformer with finite value of the permeability, and operation of the air finite the permeability. Okay, every time. So next one, operation of the practical transformer, so with iron losses. So what will happen? Iron losses are considered in the practical transformer. What will happen, or what is the behavior of the transformers? Okay, and after that, let us add one more characteristics in the ideal transformer, that is operation of the ideal transformer by considering the winding resistance. Okay, like, and next one, operation of the practical transformer by considering the leakage flux. Okay, leakage flux. And fifth one, operation of the practical transformer by considering, so that is the non-linearities in the transformer core. So that is a saturation and hysteresis effect. Okay, so this is a every time. So in the every case, okay, we will discuss about here equivalent circuit and also and vector diagram of the transformers. All of you got it fine. Suppose operation of the practical transformer with finite value of the permeability. At this condition, what is the behavior of the equivalent circuit of the transformer? How to draw the vector diagram of transformer? Similarly, one more one, the practical transformer with effect of the winding resistance. So if winding resistance is considered in a practical transformer, so how do we draw the equivalent circuit and how do we draw the vector diagram of transformers? Similar way, one more, and if the iron losses are considered in a practical transformer, and how do we draw the equivalent circuit under loaded condition and also no load condition? So these are the complete discussion about the practical transformers. Okay, and after this, okay, after the practical transformer discussion, so we will discuss about the some performance analysis. So what is the performance? One is a, what about the losses of the transformers? Okay, losses of transformer. What type of losses occur in the transformer part? So that is the copper losses, iron losses, okay, stray load losses, dielectric losses. So dependent, so whether copper losses are variable losses or not. Similarly, whether iron losses are variable losses or not. So like this we will discuss every part, and after the losses, so we will discuss about, okay, after the losses, so we will discuss about the efficiency of the transformer. Okay, this is efficiency of transformer. So that is the performance analysis. And after that, here voltage regulation of the transformer. Voltage, the regulation of transformer. And next one is a the here testing of the transformer or various tests in the transformer. So that is the open circuit test, okay, OC test of the transformer, okay, short circuit test of the transformer, and one more part is a polarity test of the transformer, okay, and next one is a the back to back test of the transformers. Okay, these are the various tests in case of the transformer part. So after the testing, so we will discuss about another important part, that is a very important per computer exams, especially in the TRANSCO and the GENCO AE or SSC AE exams. So that is the harmonic analysis. Okay, harmonic analysis of the single phase transformers, and harmonic analysis single phase transformer are that, and that is complete harmonic analysis and also switching transients. Okay, so we will discuss all this part, harmonic analysis and the switching transient of the single phase transformer. So that is what is meant by doubling effect, magnetic inrush current. So whether magnetic inrush current, whether it is a rich in the third order harmonic or second order harmonic. So what is the mean by doubling effect? Okay, these are the type of question comes mostly in the computer exam. So we will discuss very clear about all these questions. Okay. Good evening, Sweta. Good evening. You are late to this class. Okay. Any more question do you want to ask? So this is about the single phase transformer syllabus. So let us compare here also, mostly comparisons point of view, the transformer syllabus for any competitive exams. So these are the syllabus: single phase transformer, operating principle, EMF equation, construction details, ideal transformer, practical transformer, losses of the transformer, efficiency of the transformer, voltage regulation, different type of the test, and that is a harmonic analysis, switching transients. Okay. So now we have a question. So that is why transformer? Okay, what is the need of the transformer in electrical power system? So we know that electrical power system is classified into three categories. So one is a here generation of the electrical power system. Got it? And second one is how do we transmit this electrical power system, that is called the electrical power, that's we call transmission system. And another one is a the distribution system. Okay, transmission, the distribution system, how do we distribute the power to our the at consumers end. Okay, just like a residential consumers, okay, and commercial industrial business consumers. So different type of the loads. Okay, here three phase loads, single phase loads. So here electrical power system is classified basically into three categories. One is a generation part, transmission system, and also the distribution system. Okay, and we know that power is generated at generating station at a voltage of the 11 kV. So that is a power generated. Okay, in India, power is generated at generating station at 11 kV voltage. Okay, this is a the generating power voltage, the generating voltage in India. And what are the transmission voltages here? So one is a 400 kV, okay, and second one is a 220 kV, and another voltage is a 132 kV, and the 66 kV. So these are the transmission voltages. So power is transmitted at a 400 kV line, 220 kV line, 132 kV or 66 kV line. So next one, the what are the distributed voltage levels? So the distribution voltage levels, it is a 33 kV, okay, and the 11 kV. One more is a 6.6 kV. Another one is a 3.3 kV here. So these two voltages are called, okay, this is the 33 kV and 11 kV. So these two voltages are primary distribution voltage levels. Okay, primary, the distribution system, the voltage, the levels. Similarly, so these voltage levels, that is a 66 kV and 3.3 kV. So these two voltages are called as the secondary, the distribution system, the voltage, the levels. So these are the secondary distribution voltage level. And the next one here also, there are the two transmission system. So one is the primary transmission system voltage levels, and these are the secondary transmission system voltage the levels. Okay, and voltage is generated at generating station, in the generating station or power station at a voltage of the 11 kV voltage, and these are the transmitted voltage, and these are the distributed voltage. So in order to change the voltage levels, are getting point, here is a voltage changes from, okay, voltage the changes from the 11 kV to the 400 kV. Similarly, the here is voltage changes from the 400 kV to the 220 kV, 220 kV to the 132 kV. Again 132 kV is a 6.6 kV. So from here from the 220 kV to the 33 kV, so voltage changes from the this voltage level to the so another voltage levels. Okay, so by using these, so we conclude that transformer is required in the electrical power system. Okay, transformer is required in the electrical power system to change the voltage levels from sending end to the receiving end. Okay, this is the main objective of the transformer in the electrical power system. All of you got in point? So what is the main function of the power transformer in the electrical power system? So it changes electrical power from one voltage level to another voltage levels. Okay, so it changes voltage, one voltage level to another voltage level. Okay, so this is the main function of the transformers. Okay, am I right? What is your question, Sweta? Okay, sir, only one subject you recover or all? So I will teach electrical machine and power electronics. Another teacher also there in the electrical core. So to teach the electrical core subject, Surendra Bab sir, he will teach very good, and he will dealing with the one power system and measurements. Okay, are you clear point? So next one, how do we this the what is the function? Suppose we have another function. So mostly in the electrical power system, okay, in electrical power system, the power transformers are used for voltage conversion. Am I right? Voltage conversion from one level to the another levels. Okay, and next one in the electronic circuits. Okay, this is also used for the electronic circuit. So in electronic circuits, so that is a small rating of the transformers. Okay, small rating of transformer is used for isolation purpose. Am I right? The isolation of the the low frequency circuit and high frequency circuit. Isolation of the low frequency and high frequency circuit, low power circuit and high power circuit. Isolation purpose. Okay, right. And next, these are the other functions, but mostly in case of the electrical power system, power transformers are used for the voltage conversion only. So in the electronic circuit, not power transformers, only small rating of the transformer. So that is the less than the 5 kVA, that is used for the isolation purpose. So it isolates the two circuits. So low frequency circuit and high frequency circuit, or low power circuit and high power circuit. Okay, so this is also used for this the one. And next one, so in the it is also another function also used for the impedance matching purpose. Okay, the impedance matching to transfer the maximum amount of the power, to transfer maximum power through load. Okay, so here in order to transfer the maximum power through the load, what are the condition here? Always that is a load resistance is equal to the source resistance if it is a completely resistive circuit. So otherwise here load impedance XL is here, the load impedance, okay, equal to ZL is equal to ZS. So this is the complete in the impedance circuit here. So it is also used for impedance matching to transfer the maximum amount of the power through the load. So these are the other functions. Okay, is that clear, everyone? So mainly in case of the electrical power system, it is used for voltage conversion only. Okay, and next one, in the electronic circuit, it is used for isolation purpose. So one more is, it is used for the maximum, the impedance matching to transfer the maximum amount of the power through the load. Okay. So now we have a question. What is meant by transformer? Any more doubt till now? We can ask. I'm here to explain any question. If you have any question, you can ask. So now let us discuss about what is the mean by transformer. Okay, listen. So first one, the transformer is a static device. Okay, this is the basic definition point of view. So transformer is a static device. Got it point? So now we have a question, why is it why it is said to be static device, why not electrical machine? Okay, so now we have a question, why not electrical machine? Am I right? So transformer is a static device, why not electrical machines? Clear point? Anybody can answer this one? So no rotating parts. Okay, Shiva, you are right. Any other? Why not electrical machine? Why it is said to be static device only? So transformers is static device only. Why not electrical machine? No rotating parts. Okay. Any other one? Okay, listen. Any equipment is said to be as electrical machine. Okay, it must be satisfy the two conditions. So what are the two conditions? It has some rotating parts, and second one is it must be electromechanical energy conversion equipment. Otherwise you can say that a static device only. So let us take one example. Generator is a electrical machine. What is the reason? That it has some rotating parts in the form of the rotor. Am I right? Similarly, it converts mechanical power to the electrical power in the form of voltage and current. Another example, let us take the DC motor. Then what will happen? See, the DC motor has some rotating parts in the form of the rotor. That's we call armature. Am I right? So next one, it converts electrical power to the mechanical power in the form of the speed and the torque. So it means that all generators and motors are electromechanical energy conversion equipments or energy conversion devices here. But transformer transfer the electrical power from one circuit to the another circuit. So it is not a electromechanical energy conversion equipment. So it is only that converts the electrical power from one voltage level to the electrical power at another voltage levels, but not a electromechanical energy conversion equipment. So that's why transformer is treated as a the static device. Okay, got it point? So let us conclude here. Any equipment is said to be as electrical machine okay, some conditions must be satisfied. Okay, so what are the conditions here? One is a, okay, it has some rotating parts. Okay, and second one is it must be electromechanical energy conversion equipment. Okay, so a transformer doesn't have any rotating parts, so that's why it is not treated as a electrical machine. And second one, it is not a electromechanical energy conversion equipment, so it is a only electrical energy converted into the electrical energy at different voltage levels. Yes, Abhiram, power is a change, the frequency that remains same, power is also remains same, flux is also same. That's why transformer is treated as a constant power device, constant flux device, constant frequency device. So why, we will discuss in these all these reasons in the next class. Why transformer is treated as a constant flux device, why transformer is treated as a constant power device, why transformer is treated as a constant flux device. Okay, now why transformer is not a machine? What is the reason here? The any equipment is said to be as electrical machine. The here, what are the conditions to be satisfied? It has some rotating parts, and second one is it must be electromechanical energy conversion equipment. So here transformer doesn't have any rotating parts. Okay, so therefore here transformer doesn't have any rotating parts. Okay, and second one, it converts electrical power at one voltage level to another voltage level. Okay, got it? So that's why it is treated as, okay, because of these two reasons, it is treated as a static device. Are you clear now? What is mean by transformer? Let us discuss another part. So next one, we know that transformer is a design with the two windings. Basically, basic construction of the transformer point of view. So it has a two major parts. One is a, okay, this is the two major parts. The first one is a transformer core. Okay, or so this is also called, that is a magnetic core or transformer core. And next one, transformer windings. Okay, so what are the transformer windings? So one is the HV winding of transformer. Okay, and second one is LV winding of the transformer. So these are the windings. These are the major parts, okay, main parts of transformers. So one is the transformer core. It is also called magnetic core. And second one is transformer winding. What are the winding? HV winding and LV winding of the transformer. Okay. So in this case, so here we have shown the diagram. See here. So this is the diagram is a transformer, the core. Okay, it is treated as the transformer core, and it is also called the magnetic core. Okay, magnetic core. So it has some finite value of the permeability and low value of the reluctance. Why? We will discuss that part later. So here is a transformer core. Suppose we have some horizontal parts. Okay, this horizontal part, and these are the vertical parts. So horizontal parts, we can say that this one is the yoke of the transformers. Okay, yoke. And whereas horizontal part, this is the vertical parts, we can say that. So this is the limb of the transformers. Okay, suppose here this one is the yoke 1, yoke 2. So this is the limb. The limb is nothing but here. So it is that is the vertical part of the core. Okay, vertical part of the core here. And whereas the yoke is nothing but horizontal parts of the transformer core. So this is the discussion about the transformer core part. So we will discuss later very clear in the whenever we have a discussion about the construction details. And another major parts is the HV winding and LV winding of transformer. So now we have a question. What is the mean by HV winding and what is the mean by LV winding of the transformer? So HV winding means the winding which has more number of the turns, okay, is known as a HV winding of the transformer. LV winding means the winding which has less number of the turns as compared to other winding which is placed on the same magnetic core. So that is the LV winding of the transformers. Okay, suppose here we have a winding. So let us draw the winding, or let us place the winding on the core. So this is the one turn of the core like this. Okay, second turn and the third turn. Okay, fourth turn and so on. Okay, this is so HV here is some number of the turns. So let us example point here I have taken 100 number of the turns. Okay, and next one we have a one more winding is placed on the limb 2. Okay, this is the limb 1, right? So winding is placed on the limb 1 and limb 2. So next one, okay, it is the first one. This is the another part of the winding. Okay, LV winding and HV winding of the transformers. Okay, and this one is the winding which has a suppose 50 number of the turns. Okay, 50 number of the turns, and here is the 100 number of the turns. Okay, so what is the here 50 turns? The 50 100 turns means the winding which has the more number of the turns, so is known as the HV winding of transformer. Okay, this is the HV winding of transformer. And the winding which has less number of the turns is known as LV winding of the transformer. And this is only discussion while doing the designing of the transformer. So transformer is a design with the two windings. So that is the HV winding and LV winding of the transformer. And next one we have a question. So that is, what about the primary winding and secondary winding of the transformer here? The primary winding and secondary winding means the winding which is connected to the supply. So whether it is connected, suppose the supply is connected to the HV side, so it is treated as a primary winding of the transformer. So this one is a single phase, the AC supply. Am I right? So this is the single phase AC supply. So the winding which is connected to the load is known as the secondary winding. So this one is the primary winding of transformer. Primary winding. The winding which is connected to the load is known as the secondary winding of the transformers. Okay, all of you got it point. The winding which is connected to the supply is known as primary winding. The winding which is connected to the load is known as the secondary winding of transformer. So now how do we define the transformers? So this is the basic the discussion about the parts of the transformer. So one is the transformer core and it has a two winding, or it is designed with the two windings. So one is HV winding of the transformer and LV winding of the transformer. So the winding which is connected to the supply is called the primary winding of the transformer. The winding which is connected to the load is known as the secondary winding of transformer. All of you got it point? So now, how do we define the transformer here? The transformer is a static device. Suppose here, whatever power the develop. So this is the power in this case. So it is applied voltage V1. The current passes through these two windings is a I1 amount of the current, and current passes through the load is a I2, and terminal voltage here the V2. Okay, this is the V2 here. So what about the power in the primary winding? So P1 is equal to V1 multiplied by I1. So next one, P2 is equal to the P here V2 multiplied by I2. Okay. So ideal, these are apparent power V1 I1 and P2N. So power developed in the secondary winding and power developed in the primary winding of transformers. Okay. So transformer is a static device which transfers the electrical power. Okay, electrical power from one circuit to the another circuit. So or from HV winding to the LV winding, or primary winding to the secondary winding, the at same frequency. So what is the meaning of same frequency here? EMF induced in the primary winding of the transformer E1, and this the EMF induced in the secondary winding of the transformer E2. So frequency of the primary induced EMF is equal to the frequency of the secondary induced EMF one. So at the same time, the here, so number of cycles per second of the induced EMF E1 is equal to number of cycles per second EMF induced in the secondary winding of the transformers. So it has the first point here, the transformer is designed with, okay, designed with the two windings. Am I right? Two windings. And second one, so what are the two windings? One is a HV winding or high voltage winding, and second one is LV winding of transformer, low voltage winding of the transformer. So HV winding means the winding which has more number of the turns. LV winding means the winding which has less number of the turn. Similarly, the transformer, okay, the transformer, the okay, these two windings, okay, here the two windings, these two windings, these two windings are treated as primary winding, okay, and secondary winding of the transformer, right? So primary winding means the winding which is connected to the supply is called the primary winding. The secondary winding means the winding which is connected to the load is called the secondary winding of the transformer. And one more important point here, so these two windings are, okay, these two windings are electrically isolated. Okay, windings of the transformer windings electrically isolated and magnetically coupled through plugs. Got in point? So these are the two windings are electrically isolated. That means there is no electrical connection between the primary winding and secondary winding, but there is a magnetic connection. So some amount of the flux here, pi of t, so which links in the two windings. Okay, this is the flux produced in the primary winding, so also links in the secondary winding of the transformer. So how does it takes place? We will discuss the in details while discussing the operating principle of the transformers. Okay, so that how do we define the transformer? The transformer is a static device which transfers electrical power at one voltage level to another voltage levels. Okay, at one voltage level to another voltage levels at the same frequency. Okay, is that clear my point? So let us write the definition. Transformer is a static device which transfers electrical power at one voltage level to another voltage level without changing frequency. Okay, so this is the definition of transformers. Definition of okay, transformer is a static device which transfers electrical power, okay, at one voltage level to another voltage levels, okay, level without changing the frequency. Or other way also we can define. So transformer is a static device which transfers electrical power from one circuit to another circuit, okay, at the same frequency. Like this also we can define the transformers. Okay, is that clear? So this is the discussion about the transformer and what is the mean by transformer, why transformer is required. Okay, now Abhiram, Sweta, okay, any more question they want to ask, you can ask. We'll discuss the continuation in the next session. So I will give the one question. So here let's think about this question. Why does transformer rating mentioned in kVA instead of kW? Okay, or it is a why does transformer rating mention in the apparent power, okay, instead of active power? Okay, active power. This is the one other question. Very important question, right? Think about this question, answer it. And another question, relation between size of the transformer and frequency of the transformer. What is the relation between size of the transformer and frequency of the transformer? And another question, the relation between kVA rating of transformer and frequency of the transformer. Okay, all the questions. Why does transformer rating mention in the kVA instead of the kilowatts? The relation between size of the transformer and frequency of the transformer. Relation between the kVA rating of transformer and frequency of the transformer. Abhiram, that is not correct. We'll discuss this question later. Very clear. Not because of the losses. So that is the only 50% of the answer, not 100%. Okay. And about the question number 2, question number 1, question number 2, question number 3. Relation between the size of the transformer and frequency of the transformer. Okay. So think about all these questions. Think answers about these questions. Otherwise, we'll discuss the answers these questions in the next coming sessions. So these are the place batches taken by the top educators for electrical and ECE. So one is a batch number 1 is a target ESC prelims 2021 electrical batch. Okay. And this is the batch D, and rank booster batch for the gate 2021 for batch D. Another one, target ESC prelims 2021 electrical batch C. Okay, and rank booster batch for the gate 2021 for electrical students batch B. So take the subscription as early as possible. Use my code BPC10. Okay, this is my referral code. And the next one, place batches taken by the top educators for the batch. So AAA and EC. These are the evaluable batch for the gate 22. Okay, it is for EC student, the batch A, the which is in English and Hindi, and starts which starts on 21st December. So this is the 21st December 2020. These are the some of the educators are taking these batches. Vishal Soni sir, Suresh sir, Siddharth sir, and BV Reddy sir. And another batch, Evalvu per gate 22 electrical batch A, which is in English and Hindi. So which was starts on 21st December. Some of the taking these batches. Another one is Ankit Goyal sir, Ajay Gupta sir, Kwasi Rapi sir, BV Reddy sir, and Suresh ESR sir. Okay. So it is official creatrix channel which has 150k plus members. Please join in this group. And to get, it is not Unacademy Gate Telugu, actually it is Unacademy Gate English. Okay, so all of you join in this telegram group for class PDF notes. Okay, class notes in PDF form, and any announcement from this channel, you will get all the announcements. Okay, any updates, so that to get any notification, please join in this group immediately. And another one, these are the different type of the channels under the Unacademy. So one is a creatrix gate, Unacademy gate, Unacademy gate mechanical, Unacademy gate civil, Unacademy gate English, Unacademy computer science, Unacademy gate questions, electrical junction. So this is our channel. Okay, all of you share this channel and subscribe, so immediately, so for any notifications. Divya, you have given the transformer. Size of the transformer is inversely proportional to the frequency. Divya, you are absolutely correct. How it comes, I will tell you in the next sessions. It's correct. But why, the reason behind this statement, I will explain in the next class. Size of the transformer is inversely proportional to the frequency. That's correct. That is absolutely correct. But the reason behind that we will discuss in the next session. Okay, Sravs. Yes, that's correct. Actually, rating of the transformer, not only transformer but any electrical machine, designed based on the temperature rise. Okay, based on the temperature rise, that means the losses only. But during the designing, manufacturer doesn't know about the load power factor, whether it is connected to the zero point 0.8 power factor, unity power factor, or any other power factor. So that he was considered as highest power factor of the load. What is the highest power factor of the load here? 1. So if power factor is equal to 1, then the active power will become apparent power. That's why it is measured in the apparent power, or the kVA, instead of the kilowatts. Okay, in detail we will discuss in the next session. So that's correct, somewhat right. Ram, okay, AC machines, we'll discuss that part. I will discuss with my team, and I will announce you. I will continue that gate part also. Surya Narayana, okay, what's your question? When AP TRANSCO notification release in Andhra Pradesh, any idea? Right now we don't have any idea, but it will come soon. Okay, any more question do you want to ask? Otherwise, we'll stop the session here. Okay, tomorrow we will discuss about complete features of the transformers. Okay, all the reasons behind that, just like the transformer is a constant power device, constant flux device. Okay, constant power, constant flux, constant frequency. Okay, it is a 180-degree phase shifting device, negative feedback device, all this part. So we will discuss with the reasons. Target ESE 2021 batch link. So that is the paid courses, not the pre-courses, Abhiram. So if you take the subscription, you can get that batch. If question has given, you have a subscription, okay, then you can get the notification about that batch. Okay. Thank you all. Thank you very much. We'll meet once again tomorrow at 8:30 p.m. Be ready. We will discuss about features of the transformer in details, and also we will discuss another applications of the transformer very clear. So this was the discussion about overview of electrical machine for different competitive exams, especially for GENCO, TRANSCO, SSC, RRB, other state electricity board exams. Okay, so we will discuss in detail the from tomorrow onwards. Thank you.